Hello. So this tutorial is about I already created one video about the how to create the transient profile. So based on time, how to change the variable value. So this one is for spatial profile file format. Okay, how to create one spatial profile that you can use as a boundary condition in ANSYS Fluent. Okay, so let's get on with it. So this is the profile file format from you can say ANSYS user manual. Uh, so the first thing is here. This is how it should look like, the format. So it should have a profile name and point, line, or radial, the types, and n is the number of variables. Okay, I'll show you in a minute. So what's important is parentheses are used to, so these parentheses are has to be there. So these parentheses are used to limit the profiles, the bound the profile. So this is the first variable, this is the second variable, like that. Any combination of tabs or space can be used to separate the elements like A1 and A2. In the general format description, this one, so anyways, not important. So you can use either point, you can either use line or radial. And if nothing is mentioned, by default, you should take a point profile, okay? And everything has to, profile names must have all lowercase letters. And each profile type, either spatial profile, these are spatial profile based on space. So each profile type of point, line, or mesh, it has to include X, Y, and Z coordinate. Okay, if it's a 3D, then Z coordinate is necessary. And what's more, I think this should be good enough. So this is an example. I'll show you more examples. So this is the name of the profile is turbulent prof. This is a point profile. It has 8 variable values. So x coordinate has 8 values, y coordinate has 8 values, and u is a velocity. So 8 velocity at these 8 coordinate points, and some other variable values. Okay, so let's see how we can use Excel to create it very easily. Okay, so I'll show you first how a profile looks like. So I'll just write a profile from an existing simulation. So this is a very simple geometry with 10 meter by 100 meter, I think. You can take it as a cross section of a rectangular pipe. Okay, so I just initialized it with a constant velocity of 1 meter per second, and I would initialize and calculate, and it should converge very fast. So I have ran the case. So this can be useful for some cases, like let's say I want to get the outlet velocity and apply that as an inlet condition for some other case. Okay, so this would be beneficial for you in those kind of interpolation cases as well. So you can go to profile. So instead of reading, we'll do a write and define new profile. So we're gonna write it on a new file, and I'm gonna take the outlet velocity values. Okay, click write, like where to save it. So I'll save somewhere that I can easily find. So I'll save it in here. Oops, I need to put a name. Let's name something test. Okay, and click OK. So let's see. This is how the files test.prof look like. Again, the format would be .prof, and if you don't see the format, you can always go to view and show the file name extensions. Okay, then you can edit it as well. So again, this is how it looks like, and as you can see, this looks very close to this one. So let me take the example. So the name of the profile is outlet. It's a point profile. It has 10 values. So I have 10 x coordinates. It's the same x coordinates, so it's the same value. y coordinate is changing, and 10 velocity magnitude. So this is how a profile looks like, and as you can see the parentheses as well. Okay, so let's see how we can create this one with Excel very easily. Okay, so I'll close this one and open up the Excel. So if you already have your x coordinate, y coordinate, and the velocity you want to apply. So I'll just take one variable example. If you already have the velocity you want to implement in the geometry, uh, then I'll make it short. So what you can do easily is you can create an Excel sheet. So in here, like I have 0.1 increment from 0 to 1 meter per second. Okay, this is like a quid flow. This is like a quid flow example, a boundary condition, fully developed quid flow example. So I'll copy this one. Okay, I'll press Control C, or you can do right click and copy. And then what I will do is go home, paste, and paste spatial. Okay, and where to paste it? I actually should have selected the cell. So let's say I'll paste it in here, and go home, paste spatial, and I want to transpose the values. Okay, click OK. So there you go. I have everything in row, and they're separated in by a tab. Okay, in this case, the naming is important, so I'll just copy paste it. So or I can just write it down. The name of the profile. Okay, and the type of the profile, and how many points are there. Actually, I have 11 points in here. So I'll just put 11. You can check 1, 2. Okay. So I have exactly 11 points in here. So I can take this one. And so I have 11 points, x, y, and the v velocity. Okay, again, for the point, this is a 2D geometry. So I need x and y coordinate only. Z coordinate is not necessary, and v would be my velocity and the variable boundary condition I want to implement. So after that, what I will do is I'll just copy the whole thing in the row format, and I'll go over there, right click, new text document, exactly like the previous one. So this would be test2, let's say. Okay, txt format. I'll paste it, and I need to match with the parentheses. Okay, so I'll open this one. This is test2. So what I'll do is I'll put 2 parentheses in here, 1 parenthesis to close the naming, and each variable should have a parenthesis at the beginning and ending. Okay, ending and the to close the everything. Okay. Okay, so after that I'll just save it, and what I need to do is, this is in txt format, it will not be able to read. So again, you can go to view and apply file name extension modification. Just right click and rename. Right click and rename, and change the extension format to PROF. Okay. Yes, I want to change it. There you go. So this is how it looks like, and I'm gonna read this one as an inlet boundary condition now. Okay, so I'll go to Fluent, and I'll go to Profile. Okay, I don't have any profile loaded in here, so I'm gonna do read, and I'm gonna do test2. There you go, it has automatically read the name of the profile as well, and I have x coordinate, y coordinate, and the v velocity. Okay, you can close it, and then go to inlet velocity inlet, and instead of constant, now I have v velocity. Okay, I can apply this one, and then I can initialize, and after that we can actually check with an XY plot. Let's see. So XY plot, velocity magnitude at inlet. Let's see. So you can see the velocity is increasing from 0 to 1. I think I did something. I think there is the no slip condition at the wall, so it didn't go exactly to the 1 point. It did some linear interpolation. So other than that, it looks the same as the boundary condition. Okay, it's because of the initialization. All right, so if you already have uh, the values you want to put in the points, then you're done. But if you don't have all the points, and let's say I want to create more points, okay? Let's say instead of 10 points, I want to go 20 points, 30 points, okay? So how can I do that? So Fluent, if you, again, it's similar to the transient case. If you're missing some points, like in Y cases, if you want to have the value at 5.5, what Fluent will do is it will do a linear interpolation. So I'll show you how to do a linear interpolation here, and then you can manually modify it. This is not mandatory, but I just wanted to show. So this is the minimum value. I just wanted to show how to do it in Excel. There are videos in YouTube. You can follow that one. Actually, I created this one using a video. So anyway, 0, and its maximum value is 10. So this is my Y coordinate values. Okay, from 0 to 10. Number of points I want is 5. So 1, 2, 3, 4, 5 points in here. So it will automatically calculate the step size based on this equation. So D3, this one, maximum minus minimum, divided by the number of points minus 1. Okay, so you can use the step size for use the minimum maximum values and the number of points to calculate the step sizes. Okay, so this one is for Y, this one is for V. This is the formula I used. Okay, and what we can do is like this one is equal to the minimum values. You can see that. Okay, okay, so the same goes for this one. V is equal to the actually I inputted it manually, so I can do this one. Okay, so this one is equal to the minimum velocity values as well. So after that, to create the 5 points, you can either add, but let's say imagine instead of 5 points you have 50, you have 100 points. Okay, so you don't want to put manually and drag and drop this hectic process. So there is an easier way to do that. Select the minimum values, minimum point, go home, go editing, and then there is a fill option in Excel. Okay, so click this one, click on the series. So I want to create a series of points. Okay, so will it be in rows or it in columns? Okay, so I'll select columns. I should have deleted these values, but anyways, let's create one more point so that you see the change. So I'll do it in column. It would be a linear growth. Step values would be my step size. So 2.5 for Y. Stop value, the final value is 10. Okay, so I'll do 12 just in case, just so that you can see the change. Okay, click OK, and what happened? Let me do it again. Fill series in columns. Step value is 2.5. Stop value is, let's say, 16. Click OK. There you go. I think I did something wrong. Okay. So with 2.5 step size, it went up to 1.15. Then adding after 15 would be more than 16, so it didn't take the last values. Okay. So this way you can very easily create your column of Y and V. I'll just delete these two. This one I actually plotted using these two uh, values. Okay, these two columns. Okay. So this is my Y, this is my so from 0 to 1, this is my velocity. In x-axis, this is my Y coordinate. Okay, and you can see this is a very linear velocity profile with a slope. Now, how to create more points instead of these 5 points? So what I did was I used a linear interpolation formula, which is this one. Okay. So the new y value, so this is my x1 y1, this is my x2 y2. Let's say I want to have points in the middle with a linear with the same slope. Okay, linear relation. So it would be, the new y would be y1 plus x1 x minus x1. Okay, this x minus x1, this one, times the slope. So this is y2 minus y1 divided by x2 minus x1. Okay, so I'll use this formula to create this velocity. Okay, this would be my y value, this would be my v value. Okay, so y is similar to that x, this v is similar to that y. Okay, anyways, so this would be my input value, and this would be my output velocity value, and this is how I'm interpolating it. Okay, I'll show you the formula so that you can copy it. So I need the smaller y value, which was y1, and the larger, which was y1, the smaller values and the larger values, these 2 points. So how do I get that from these just 5 points? So instead of 5 points, I have to have maybe 100 using the linear interpolation. Why? I will show you to that. So what I did was I found the smaller y values using a VLOOKUP function. Okay, so what it did was it looked into the C8 cell, which was this one, then comma, and then what I did was I selected, instead of the all of them, I should have actually, because I'm looking for only y, I could have done this one. Okay, so actually you can do it this way. Let me show you this part how I did that. So I can just select this one. Okay, and as you can see, this would move if I drag and drop. So to make this one fixed, you can put the dollar signs manually, or you can do function, yeah, you can do press F4, so that would add the dollar signs. You can keep pressing F4 to change it, but I want it fixed. I want this column fixed. So I'll apply dollar on all of them. The one means the first column. Okay. Actually, I can use this one to do both. That, I think that was the reason I selected both the columns. I'll do just that. Okay, I'll show you why I did that. So I'll fix it. Okay, and this one means among these two columns, take the first column values only. Okay, don't take the second column values. And the true means, don't take the exact 2.5, but take the middle points as well. Okay, like 1. Okay, so if you don't say true, it would not calculate the other values, so it would not take in between them. So anyways, y larger is the okay, the v smaller. V smaller is the same formula I used for y smaller, but the only difference is these two. Okay, instead of the column number 1, I'm taking the values from column number 2. Okay, I'll cancel it. I don't want to press escape. Okay, so this is how you can get the smaller values. Okay, for the second column. For the larger values, so what it is doing is it's checking for uh, the the y value, and it's going to check the whole column, and it's finding which one is closer to uh, this 0, or let's say this 1. Okay, and then it's taking the smaller value of that existed in this column. Okay, so it's going to take 0. So it again did the same thing for 1 as well. If when it's looking for comparing 1 with this column, it found that 0 is smaller than 1, closest to the 1 value, so that's why it's taking 0. But for example, for 7, when it looked for here, it found out that immediately smaller than 7 is the value 5, so it took the 5 value. Okay, so on and so forth. For the y larger, so what you're doing is using a trick. So we have the smaller values. We are using that smaller value to detect the cell and then adding, like jumping to the next cell and then taking that value over here. Okay, if it's the smaller value when checking for the values in y, then definitely the next one is going to be the larger values as well. Okay, so the point is going to be in between these two smaller and larger values. So how do we do that? So I'm using two functions. Again, if you're confused, just copy paste it as you see in the video. So what I'm doing is initially I'm using the match function. So what it's doing is it's checking the smaller values d8, okay, these smaller values, and then going to this column to check for where is the location, okay. Okay, then it found that this is in J1 to 3 4, it's in J4. Okay, then it's adding one more cell to it, so it's jumping to J5 using this plus sign, and then I'm getting the position using the match function. Okay, the position of the larger value. How do I get the value from that position? So I'm using an index function to go over uh, this whole column again and checking with the position given from the match. Okay, again I'm making it fixed. I already showed you how to make the column fixed. Just press F4. This dollar sign should come, or you can put it manually as well. So this is how I'm calculating uh, the larger values. Same went for V larger as well. Okay, it's checking the V smaller and then going to V column and finding the V larger. Okay, what I did was then how am I calculating V? V is exactly this formula. Okay, exactly this formula. So Y, which is V in our case, is equals to Y1, and the formula I'm using for the linear interpolation. So this one, and then you can just, based on these Y values, you can get all the V values you want. Okay, I used different values, and I think the last point goes haywire because I don't have a V larger and V smaller when I'm checking the last values. It's just manually put the final values. This is how it looks like. Why did I do that? The linear interpolation, it's because let's say I want to tweak the velocity profile, but I need more points. Okay, so with this Excel file, you can add more points, and then let's say I want to, instead of zero point 0.4 after 0.5 after 0.4, I want to increase it by 0.6. Okay, I want to change the velocity by 0.9. Okay, so any way you want, you can change the values. uh, Actually, you should not do it in here because the formula will erase. So what I recommend is you can just press Control, copy the two columns, press Control C, and you can go to the previous sheet and click over here, paste it. There you go. You have all the values in here. You can plot it and take a look how your velocity profile should look like. And then again, the same way, you can copy it and paste it as a spatial and transpose. Okay, I should have selected that. I should have selected the cell actually. Paste it as a spatial, transpose. There you go, and you can just copy paste it. Okay, so 10 values, and then I can just copy and paste it in my velocity profile. Okay, paste it and then just add the parentheses. Okay, and then you can see the x, y, and the v values are different. Okay, x didn't change because x is constant, at the inlet, which is 0 in my case. But Y is not changing as well because I still did 10 points. But V, you can see like the way we changed 0.4, then 0.6, then 0.6. So this way you can modify your velocity profile the way you want. It can be very useful when you're actually doing, trying to do a pulsatile flow. Actually, that is time dependent, but anyways, like you can apply uh, turbulent type boundary condition, okay, which has a big variable velocity. So this way you can apply. Then again, go to Fluent and parameter. Sorry, profile, and you can delete the old one. You can delete the old one and read it again. Okay. So this is the new one, and you can apply it over there and run the case. Okay. So this is how you can write the profile. So in summary, what we did was we learned how to write the profile. Might be used for interpolating and using it as a boundary condition for other simulation or cases, then or plot it as well. And then you can then we saw how to create the profile if we already have the points, x, y, and coordinate points and the variable values. You can have multiple variables as well. Okay, and we learn like velocity and temperature, and I showed you how to do a linear interpolation. Again, if you're not doing linear interpolation, like not giving enough points, Fluent will again, it will by default, it will do a linear interpolation in between 2 points. Okay, for the values, let's say for 1.5, it will do a, I don't have 1.5 y coordinate and the v velocity for that, so Fluent will do linear interpolation for that for you. Okay, so unless you have a curvature or any variation, just go with 2 points or 3 points. That should be good. Fluent will do it for you. But if you want to vary or fluctuate it, then this is how you can get more points and change it manually. I hope this can help clarify a lot of issues. Thank you.